Hello, and welcome to the brand new section titled Better Java. Now, let's move on to the next video. New, more concise syntax, local variable type inference, var, and more. One of the major complaints of people who don't like Java is that the code written in Java has too many letters, meaning that it's too verbose and redundant. Local variable type inference partially addresses this problem. Local variable type inference, also known as the var syntax, looks like this. It looks simple, but we will spend an entire video to experiment with it, and you will see why. So, in this video, what is var and what it's not? We will do some cool and unexpected things with var. And we will also outline bad practices, not so cool things you can do with the var. It will be very hands-on. Let's get started with the demo with cats. Var syntax was introduced in Java 10. Let's take this code written without the var identifier and simplify it together. String cat equals check. We can replace the explicit type declaration string with var here. Looks shorter, but not a lot. A list of strings cat names. Let's replace a list of strings with a var. Looks much better now. Yeah, okay, a multi-map now. It looks ugly. A map with string key and a list of string values. Here, a var can be really helpful. Yeah, it works. We only saw the examples of local variable declarations so far, but we can use var in a for loop, like here. For var I equals 0. Or in a try with resources. It's more helpful here. Look. Let's run this code. It compiles, it runs, it works as expected. You should now have a general idea of how to work with var. But can we go further? Where else can we use it? Can we use it in a method signature? Let's give it a try. I have this method, getFavoriteFood, with a string parameter cat. Can I use var? No, I cannot use a var in a method parameter. How about a field in a class? Here we have a public string jelly. Can I use a var here? No, it's red. It doesn't compile either. So the var can only be used for local variables. I have another idea. Some other languages use var to indicate that a variable is not final and its value can be changed. And they use val value for final variables. Can I do val in Java? Let's try it. No, it doesn't work. I'll change it back to var. The reason val doesn't work in Java because the var only denotes an implicit type. It is completely orthogonal to other concepts. For example, I can make a var variable final. Or I can create a non-final variable and change its value later. It works. How about this? I'm assigning a value of a different type. It was a string and now it's an integer. No, it doesn't work. Incompatible types. Because the type is preserved. Java is still statically and strongly typed language. Okay, I cannot change a type of a variable. What if I use var and do not assign a value? Or what if I assign but null? What do you think will happen? No, it doesn't compile like this. And assigning null. Yeah, we've got an error here as well. It will not compile. And the last experiment in this part, I have a variable called var. Can I use var with a var? Yes, it compiles. I can. This code compiles because var is not a keyword, as it might look like. It is a reserved type name. Therefore, you can still name your variables var and even use the var identifier with the var variable. You can, but you shouldn't, because var is a poor variable name. I can summarize this demo with 4 words, which is also official name of var in Java: local variable type inference. It is type inference as it infers type. It calculates the type based on the value. It infers type and does nothing else. It doesn't indicate if one can or cannot modify the value, for example. And this type inference is only applied to local variables. We can use it in a local variable inside methods, inside the for loop, inside the try with resources, but we cannot use it anywhere else. We still need to explicitly specify the type for field and method arguments. So var in Java is local variable type inference, nothing less, nothing more. Let's get back to our demo and do more advanced things. I have an object Ella of anonymous class which has the fields name and description. It's useless now because I cannot use these fields values. Look. I cannot access the name, for example. It doesn't compile. But when I use the var, let the magic begin. Now, with the var, I can access the fields from the anonymous class, something I wasn't able to do before. We can take this example further. I already defined and populated a map of cats with description. We can process these elements and we can use an anonymous class inside the lambda expressions in a stream mapping and assign it to a variable with a var. Here it's a var. So it's a stream of these cat objects. I built this stream of temporary objects and I can use it later inside the same method. For example, let's print out information about these temporary objects. I can now access cat name here, and cat name was defined inside this anonymous class. And similar with cat description. You see, I can access the fields of an anonymous class. Cool, huh? Not only var makes the code more concise, more readable, and more maintainable, it also allows us to do more with our code. It adds new functionality. As you just saw, we can access the fields without defining a class. And the latest addition to the var functionality is var in lambda parameters. We have this lambda expression with 3 parameters and explicitly defined types. From the very beginning of lambda in Java, since Java 8, we were allowed to do this. I'm removing the type. So the type was already implied since Java 8. Now, in Java 11, we can use var in lambda parameters, like here. Doesn't look more concise, right? What's the big thing then? What's the use of this feature? The big thing is that we can use annotations with var, like here. If we try to do the same with the old syntax, see, it doesn't compile. Annotations drive many frameworks. They can be used for runtime validation, for example. So, starting from Java 11, you can use var for lambda parameters. And before we finish this video, let me spend a minute talking about what not to do with vars. The goal of the vars is readability and maintainability of the code. So the next person who works with the code enjoys working with it. And what you can see here, var x, is something that we should be avoiding. X is a bad variable name. It doesn't tell us anything about what this variable does. It was a bad name before vars, and it's even worse with the vars, because now we don't have the explicitly written type. Another thing is the principle of the least surprise. This code does have surprises. What's the type of the cat variable in your opinion? If you think this is a list of strings, well, I can add a boolean. I can add an integer. It's a list of objects, but it looks more like a list of strings. In this case, var does not add to readability. We should either remove var and specify the type explicitly, or use the right part of the assignment to specify the type of the list. It's very important to maintain the code readable by using good variable names and avoiding surprises. To summarize, var was introduced in Java 10 to make Java more concise. Its only goal is type inference. It doesn't do anything else, it's orthogonal to the final keyword. The var can be used only for local variables and nowhere else. It cannot be used in method parameters or fields. Starting from Java 11, var can be used in lambda expressions, which can be helpful because it can be combined with annotations. The goal of var is to make the code more readable and maintainable. We should keep it in mind and give our variables good names.